Hello everyone, welcome to today's lecture. In this lecture, we are going to learn about the Booth's multiplication example, that how we can solve the Booth's multiplication, how we can perform the multiplication with the help of Booth's algorithm. Okay, so let's start. So suppose these are the two number minus 9 and minus 13. So these are the two signed number, and if we want to perform the multiplication of this two number, yes, so at that time we are using the Booth's multiplication algorithm. Here 9 is the multiplicand and 13 is the multiplier. Okay, so let's start how we can do this with the help of multiplication algorithm. So to perform this, initially we need the things which is a qn plus 1, value of AC, value of QR, value of qn plus 1, and sequence counter. All this the things I already explained in the previous video, that what is a QR, qn plus 1, SC and SC. Okay, so here the binary of multiplicand 9 is 10111, and the binary of minus 13 is the 10011. Okay, so here in this initially the value of AC register will be 0, and because it is a 5-bit number, here this 9 and 13 is the 5-bit number, so that is why we are writing 50 here. Second is the QR, value of QR. So in the QR we are storing the value of multiplier. So here the multiplier is 10011, so that is why we have write here 10011. Initially the value of QN flip-flop is 0, and the sequence counter is 5, because the number on which we are performing multiplication is the 5-bit number. So that is why we have write the sequence counter value 5. Okay, now let's find out the value of Qn. Now value of Qn is the LSB value of multiplier. Here the LSB value of multiplier is 1, so that is why we will write here the value of Qn is 1. Okay, initially we have the value of Qn 1, Qn plus 1 0. Now the value of BR means multiplicand is 10111, and the complement of this value BR bar plus 1 is 01001. We have write this value here because in this video we will use this value for the further calculation. Okay, now in our previous video we have seen that if the value of Qn and Qn plus 1 is 00 or the 11, at that time we'll directly perform the arithmetic shift right operation. Now if the value is 10, at that time we'll take the 1's complement, we'll take the 2's complement of the number and add it to the accumulator. And if the value is 01, at that time we'll add directly the value of BR to the AC register. Okay, so now let's compare it here. Here the value of Qn and Qn plus 1 is 10, so we'll performs the 2's complement of BR and add to the accumulator. So here we have already calculated the value of BR bar plus 1. So what we'll do here, we'll add this value of BR bar plus 1 into the accumulator. So here 0 1 0 0 1, and we'll add this value. So the output is become 1 0 0 1 0. Okay, same as the value of QR is 1 0 0 1 1. The Qn plus value is 0, and the SC value is 5. Okay, after that to perform the multiplication we are performing the arithmetic shift right operation. So to perform the arithmetic shift right operation, we'll consider the first sign bit as it is, and then we'll shift all bit right to 1 position. So this is 0, then 1, then 0, then 0, then 1, then 1, then 0, 0 and 1, and this 1 will shifted here and will decrement the value of sequence counter 4. So now you can see here the value of Qn plus 1 become 1. So we'll update the value here from 0 to 1, and also in the QR the LSB bit is 1, so the value of Qn is 1. Okay, so now let's perform the let's compare the value of Qn and Qn plus 1. If both value are 1 1 or 0 0, at that time we are directly performing the arithmetic shift right operation. So here we will use the first sign bit as it is, and then we'll perform the arithmetic shift right operation 1 0 0 1 1 0 0, and this one will shifted here and will decrease the sequence counter value 3. Okay, now the value of Qn plus 1 is 1 and the value of Qr is 0. Now the output is become 0 1. Value of Qn and Qn plus 1 is 0 1. If the value of Qn and Qn plus 1 is 0 1, at that time we'll add the value of Br into the AC register. So the value of Br is 1 0 1 1 1. So here we'll add 1 0 1 1 1 and we'll perform the addition operation. So the addition operation is something like 1 1 1 0 1 1 0 1 1, and the final value of QR is 0 1 1 0 0. Okay, so now this is the final output. So after that we have to perform the shift right operation. So for that we'll consider the first sign bit as it is and perform the shift right operation. And this 0 will be go here and decrease the sequence counter value by 2. So now you can see that the value of Qn and Qn plus 1 is 0 0. So if both are 0 0, at that time we will directly perform the arithmetic shift right operation. So here we'll consider sign bit as it is, then we'll shift each bit by 1. And this 0 is go here. Now the value of Qn and Qn plus 1, value of Qn is 0, so we'll write 0 here, and the value of Qn plus 1 is the last bit of the QR, which is 1, so the output is become 1 0. So when value of Qn and Qn plus 1 is 1 0, at that time we'll add the Br bar plus 1 into the AC. Here the value of Br bar plus 1 is equals to 0 1 0 0 1. So 0 1 0 0 1 and will performs the addition operation. So 1 1 1 0 1 1 0, and the carry bit is 1, so we'll discard this carry bit, and next bits of QR are 0 1 0 1 1. Okay, and then we'll performs the arithmetic shift right operation. So we'll consider the first bit as 0, then 0 here, then 0, then 1, then 1, then 1, then 0 1 0 1, and this one is moved here, and the value of sequence counter become 0. So here the final output we'll consider here is this. Okay, so this is how we can perform the arithmetic operation, or this is how we can perform the Booth's multiplication with the help of Booth's algorithm, and will perform this cycle until the value of sequence counter become 0. Okay, so I hope now it's clear. Thank you so much.